Hi, I'm Alex. Today we're going to be talking about the article Exercise Physiology of Normal Development, Sex Differences, and Aging. So this article primarily talked about the differences in sex and aging and how those affect homeostatic balance in the body and the body's response to stress. Um, it was found that physical activity early on in childhood is really important for disease prevention later on in life. And this applies even to movement during fetal development and in infancy. And these help to start physiological processes in children, which later prolong lifespan and um, health in terms of maintaining homeostasis in the body. Um, it was also found that previously children and adults were kind of assessed under the same health criteria, but we can't necessarily do this because the physiological systems within a child versus an adult are very different. And children aren't just miniature adults. There are different criteria needed to assess health in children and in the health of the homeostatic balance that they can achieve. There's also a big emphasis on sex differences as they apply to physical performance and physiology. Um, One of the main points was that hormones are a big impact on an individual's tolerance to exercise and ability to recover. Specifically, estrogen and progesterone in women affect functions such as breathing rate and fluid retention, which affects blood volume. And these are important um, in systems that regulate, thermoregulation and recovery in response to exercise. Um, and one of the other main points of this research paper was that although modern technology and different advances in medicine have increased lifespan, with an increased lifespan, we're also seeing an increase in sedentary behavior. So this is in part due to the fact that as people get older, they are less tolerant to physical activity and exercise, and also the processes in the body that regulate homeostasis are no longer as effective. And so people are becoming more sedentary as they're older. However, this is also kind of a cycle because with less physical activity, they're just further decreasing their ability to regulate homeostasis within the body.
Hey guys, for this presentation, my portion was methods. This article is based on 350 studies, and because of that, there were many references and experiments analyzed to illustrate the bigger picture. The first experiment I found significant was done to comprehend the mechanism of gas and metabolic gas exchange in response to exercise done by children. The children are engaged in high intensity activities for an average of 22.3 minutes and a median of each activity of 3 seconds over 12 hours. All activities lasted less than 15 seconds and showed that children participate in short bursts of physical activity in different intensities. Many studies observed the assessment of muscle oxidative metabolism and glycolytic activity within the muscle in children. These results were also compared to adults. 31P nuclear magnetic resonance spectroscopy is used on children to observe the pi, phosphokeratan, and pH levels, which is useful in this experiment. And also, the variable being analyzed can evaluate the intracellular glycolytic levels and metabolic in children. But there are different samples, and a number of participants were used of many studies. And one of the study consists of 10 pre-behavioral children, which has 8 boys and 2 girls, and another similar study, which is Rydell study, that had about 8 boys. Next, when comparing genders, there are some published data regarding temperature, corrected arterial blood gas, and in relation to pulmonary gas exchange. One specific review examined pulmonary gas exchange during exercise and how it differs from each gender. This review studied about 57 women and 35 men. This was done to show the difference in relationship of ADO2 VO2 between men and women. Another study was to understand if the rate of muscle strength and power decline in those who perform regular resistance exercise. And for that, a master weightlifter and untrained were compared, and the adult differed in a variety of ages. Overall, the subjects all showed a relative decline in strength and power as age increased. There are now many studies on influence of exercise on vascular function and structure. One study from the Baltimore Longitudinal Study of Aging examined how aerobic exercise might reduce the age-related increase in arterial stiffness. Those who performed the endurance exercise regularly had a lower level of pulse wave velocity and carotid augmentation index. They also did a 3-month follow-up to see how influential walking daily and the relation to overall arterial stiffness. Yeah, these were some of the experiments and that were discussed in further details, and also the experiments that were significant. Next is Mayawa with the results.
Good morning. The graph on this right side is showing data for activity performed by some children. The activity ranging from low to high intensity. And each participant VO2 was monitored for 10-minute bout. Even though the highest intense activity was not more than 10 seconds. The result shows that 5% of moderate reaches their threshold during the activity, and 26.5% of high intensity reaches their threshold during the exercise. Children are also known to have brief bursts of energy during activity, whether physically or whether they outdoor. They are known for having brief bursts. So it is difficult to understand their tissue breakdown, their growth, and development for this study. On this graph, we're looking at high intensity exercise versus O2 usage in adults and kids. More oxygen is used during high intensity exercise in children, which means they are less dependent on anaerobic than adults. During exercise, lactate level in respect to high intensity exercise are smaller in children than in adults. On this slide, comparison between arterial blood gases, partial pressure of oxygen, and partial pressure of carbon monoxide between men and women were considered. The arterial blood gases is less in women compared to men at any level of VO2. However, alveolar ventilation is not reduced in women compared to men at the PaCO2 is lower in women at any given VO2. It is evident that Females have a higher life expectancy than men for many years. Even though the general life expectancy continues to increase, women continue to live longer than men based on how the graph is going over years. And this graph is only saying one thing. As people get older, many features start to decrease. For example, their total lungs, their balance, peak muscle strength, flexibility, and maximal aerobic capacity. All this start reducing as people start getting older. And the decrease starts around the age of 30. Thank you.
So an increased lifespan is achieved through different advances that we've seen in technology and medicine, as well as our understanding of the human body. But as people get older, they tend to be less active. And again, this is due to their decreased tolerance to exercise and their ability to regulate their body in response to stress. Specifically, the average female lifespan tends to be longer than that of males. So we're seeing an increase in older people, specifically females who are inactive. And the relevance of this research paper, if we apply it to, the real world or a clinical setting, is that starting physical activity early on in childhood not only kind of reinforces the habits of a healthy, active lifestyle, but it also starts processes within the body that later on help to prevent disease, help to prevent chronic illness, and help to prolong the physiological processes that promote homeostasis and help the body recover from exercise and stress. Thank you.